Good afternoon, everyone. In this lecture series, we are going to see about the scattering parameters and the properties of S matrix. So, before entering into the topic, we have to know why scattering parameters. So, what is the purpose of the S parameters? The S parameters, it is used for the high frequencies. Some of the disadvantages in the low frequencies because it cannot be measured in the accurate. So the measurements is very important in the microwave, and we are using the Z parameters, Y parameters, A, B, C, D parameters. So these are all the disadvantages in the S parameters. These are all the disadvantages in the low frequency parameters. That is what we are going for the S parameters. So the S parameters is nothing but the high frequencies. So here, what is the purpose of this S parameters? Why it has been used here means there will be lack of suitable measurement tools. The tools will be lacked, and the frequency measurements will be in the form of limited. So these are all the challenges we are facing. So what are all the losses we are using is, that is signal degradation. So suppose if some of the data that has been transmitted, so there will be some signal degradation and the energy will be dissipated. So what are all the reflection issues we are going is, there are two types. It depends upon the material properties and the impedance mismatch. So this system design what we are using is, one is complex circuit, another one will be your component integration. So what are scattering parameters? How it has been reflected in the microwave networks. So we are having four categories. One is S parameters, linear microwave networks, incident waves, another one will be your reflected waves. So S parameters, it's relate the incident and the reflected waves. Here in linear microwave networks, we are going to see where the S parameters has been used and where it is applicable. Incident waves means the waves entering into the network. The reflected waves bouncing back from the network. So these are all the parameters. So the matrix for this representation is, we are going to take the output in the form of B1, B2. That is, already we know that S matrix representation S11, S12, S21 and S22. So here the matrix is divided into reflection coefficient, transmission coefficient and multiport network. The reflection coefficients is nothing but the reflected waves. The transmission coefficient is nothing but the transmitted waves. The multiport networks is nothing but the complex network analysis. This is what we are describing the S parameters. So here the signal reflected back from the input, that is termed to be as the input reflection, and the signal reflected back from the output is known as the output reflection. And here we are having forward transmission and reverse transmission. In forward transmission, the signal is passing through the output, and in reverse transmission, the signal will be passing back from the output. These are all the parameters. So here, why S parameters are powerful and what is the difference between? So while taking the advantages, it is easily measurable. There will be high frequency and there will be a direct power relationship. But in the disadvantages, the main thing is calibration is very important. So that is needed. At the same time, the equipment is costly. What are all the properties of the S parameters? So here, though we are having some of the properties, that is no information or the energy is lost during the operation, and the parameters maintains the magnitude, and there will be integrity. So these are the properties of the S parameters, and we are going to validate and measure these parameters. So how we are going to validate means, the first thing is we have to know the functionality and the efficiency. Automatically, if there is minimum number of power loss, we can easily calculate the efficiency. And there will be a tool for measuring the RF and microwave devices is nothing but the vector network analyzer. Suppose if the power is reflected back due to the impedance mismatch, what happens? The return loss will be carried out. The insertion loss is nothing but signal power loss due to the device. While coming to that of the applications and future, we are having the amplifiers, filters and attenuators, antennas and RFICs. These are all the things we are using in the S parameters. It is a high frequency parameters. So this is the mind map, how we are differentiating and why the S parameters has been used. So this is the assessment question. Why scattering parameters are preferred means power measurement is more convenient, and the S parameters relate the incident and reflected waves. The parameter S11 represents the input reflection coefficient. Thank you.